mutually both agree regarding the outcome of the operation, outline of the operation, and what are the minimum safety standards that both parties are going to. Okay. So first we will watch a video about management of say fire hazard and those other related.
Somebody came and did something over there. Yeah. The break.
Who came?
Looks like he was a technician, right? Yeah. No, it seems that he's working here, but I don't know what he has done. He came from that room.
From the room between these two bridges.
Yeah, from the that thing is wireless, yeah. They have in every room. If they have, you don't have to touch.
You take the password from downstairs?
No, it's not there. I sometimes connect to Jerome and sometimes not.
Well, every day try several times to connect to the room, so well,
yeah, it's very
connected now.
Sometimes connect, sometimes.
Now you have to try and make find.
No, it's like automatic. Sometimes connect, sometimes not.
Yeah, I'm drinking this Wi-Fi outside. I'm using this Wi-Fi as a easy. You have to connect.
So, Leo, like, can you talk to Evangelos about, like, if you can arrange something like a attendance list, like a kind of like.
I think you must have changed the HDMI here.
Yeah, like not like a call, of course, not because, but at least like, this guy attends to LNG driven ships, blah blah.
And the power supply.
And also, I think that they will give us.
No, they say
for the speaker. It was working before. I left from the
because we need it.
There's no power supply here.
So we have.
but no attendance is the kind of official letter that signed by Universal Satellite or the last of course like this guy like Mr. Leonard attend to LNG driving blah blah of course.
No, just remember. Actually, last week your name was promoted to.
Okay. But again, the important thing is like kind of a document. So the attendance.
Do you want? If you tell me for whom you will for ourselves. Everything the TV.
Yeah.
If it is for the ship, you will have from the email another one. And after the end, this is what I sent for 20 minutes for here. They will send the outcome with some other stuff that they might have missed. And after a month or something, 2 months. This is what recognition.
But there was
So each of you
what was the problem?
will have a certificate.
The
they were great.
Okay.
That's the after years,
Yeah.
for one.
Okay.
Can certify that you.
Oh, yeah.
Don't worry, if it is about this,
This is what I'm talking about.
yeah, if it is for another reason, tell me to.
No, there is not going on in
That's the important thing is to have our name and the name of the course and like an official sign. Okay, that's okay. Yeah, that's okay.
video is, there is no
But
audio.
the problem is
Audio is because I connect my
I'm doing my rest and they are
Slow.
yeah, very slow. They are very
And so they probably see
hopefully not, because the program is finishing us. Not to collect everything.
yeah.
So they will answer. And after that they will know they will be faster. So the next module will be in Greece, right? Then will be the last one.
Why
Will be from 23 to 27 November.
What's the other
Propulsion. It's sheer technical.
It was all actually all 100% okay before.
Who provides that?
I don't know, it didn't have to remove anything.
Right.
The airplane.
Everything was working perfectly fine.
But it can be provided.
So last month.
I think I will start with a new proposal.
When?
You want to get a CD phone.
Yeah. When? No,
I think
they
power supply is
Greece.
just one now.
Okay, but if there
Can
is
you make it everything like what it was
a
before?
wide number of like if you are all of you would like to participate, we will have a room
This
like
is coming
this,
directly from here.
and we can
If you connect with the
Yeah.
line, yeah. You should show transfers. This one. Yeah, DC of this. That's one. This one I used to connect when I needed for this one. So everything was. Yeah.
I know
Just make it backwards.
This can be
Okay, guys. If you're watching this video.
Gas. Liquefied natural gas. Liquefied petroleum gas. Methane. Propane. Butane. All valuable clean burning fuels. Compressed or cooled into liquid to make it hundreds of times smaller. It is transported safely in more than 1,000 vessels around the globe. Contained, it is safe. But when it escapes and mixes with air, with such low flash points, all it takes is a small source of ignition. If the fire is not contained rapidly, the results are potentially catastrophic. Fire. 4 letters describe a very serious. 4 letters to describe the F-I-R-E. extinguish. Finding a fire is relatively simple. But better still, to detect escaping gases before they ignite. The problem is that both LPG and LNG are odorless and colorless. There's As the vapor is cold, it will often cause a visible mist
Do you know how they make
and will
it?
flow downhill like
There's
water.
no smell and you can see.
But the flammable gas cloud, especially with LPG, may extend well beyond what can be seen,
Like garlic.
and any flame will travel back to the source. There are important differences between LPG and LNG vapor. LPG is heavier than air, so it flows downhill and stays on the ground. LNG initially flows downhill and then rises as it heats up, so the ignition risks for each may be different. The IMO IGC code specifies that vessels must have fixed detection alarms set at no more than 30% of the lowest flammable limit in enclosed areas, such as cargoes, machinery rooms, electric motor rooms, and accommodation blocks. Some systems are designed to shut down automatically 60% of the lowest flammable limit. Terminals also have vapor and fire detection systems, and their firefighting and mitigation system will be installed according to local requirements. Vessel crews and terminal staff should keep each other fully informed about any fire or potential hazard. If you find a fire or unignited gas, it's important to raise the alarm immediately. The ship's master or terminal manager will then inform those who need to know, such as the local fire brigade. And the port authority. Most vapor emissions and liquefied gas spills do not result in fire. On both terminals and vessels, electrical equipment is suitable for use in hazardous areas and should not cause ignition. Should these mitigation measures fail to prevent ignition, there are two main types of fire that could result. Pool fires, which are often in contained areas, such as a pump, and jet fires, which are often caused by a failure of a pressurized valve, pump, or a pipe. Pool fires are normally tackled first. As these can cause the failure of pipes and valves and reignite extinguished jet fire. Respond quickly. Time is of the essence in firefighting. Both vessel and terminal start their fire pumps. Deluge system, water curtain, and foam generators are brought into action to restrict the effects of the fire. Water spray can be used to effect boundary cooling, create a flame barrier, or to disperse the vapor cloud. If one tank is on fire, nearby tanks are protected with a deluge system. The source of the gas is located and cut off remotely if possible. Firefighting teams are mustered, and the correct personal protective equipment, including breathing apparatus, is prepared. Hoses are run out and crews move to their firefighting position. Now comes the crucial decision, whether to extinguish or control burning and then extinguish. The decision taken will depend on individual circumstances, such as whether the fire is heating vulnerable machinery, pipes, valves, or storage. Will heat damage these and create further gas or liquid escape? Which is the greater danger? Extinguishing and allowing unignited gas to escape, or allow the fire to burn? Often, unignited gas is more dangerous than fire, as, in rare instances, it could lead to a vapor cloud explosion. How much gas is likely to escape, and where will it flow? This depends on wind strength, and whether it will flow over open water or industrial land. Is it likely to disperse harmlessly, or pool somewhere? Potential ignition sources downwind should be considered, such as vessels, port facilities, and houses. Often, the decision is taken to allow the gas to burn off while the source is isolated. For example, a pool fire in a bunk where no vital equipment is vulnerable. A jet fire in a fractured pipe is likely to provide a different set of challenges and pose different questions about the risk. Here, the automatic valve operation failed, and the jet fire is threatening pipework. The master decides to close the valve feeding the fire manually. Each team of firefighters consists of a nozzle man with a backup hose man to resist the back pressure and a third crew man to manage hoses and valves. Two teams advance on the valve with a water source. The firefighter tasked with closing the valve is positioned in between. The nozzle man creates a wall of spray to protect the valve closer and cool the area. The valve closer is careful not to venture beyond the spray and to ensure the valve is cool before closing it. Nozzle set to hollow cone can cause a vortex, attracting flame to the nozzle man. It is essential to stand firm, however intimidating. If the valve is damaged and vapor cannot be controlled immediately, the water jet can be used to deflect the flame up to 90 degrees away from vulnerable systems. Care must be taken not to extinguish the flame. Although ignited gas is often safer than unignited, deliberately igniting gas can be very hazardous. There is no knowing how far it has spread and where it has cooled. Every second counts. As containment vessels heat up, liquid gas boils, creating ever higher pressures. But LNG and LPG boil in different ways. LPG boils off faster, making it harder to control. If, due to flame impingement, the vessel is weakened, and the pressure builds within the tank beyond the point where the pressure release valve can cope, it's possible to have a boiling liquid expanding vapor explosion, or bleving. When unignited vapor is confined or contained, it is also possible to have a vapor cloud explosion. important differences between them. LNG is stored at -162 degrees Celsius. It is so cold, it can crack steel plates and cause severe frostbite. Liquid LNG can also reduce the effectiveness of protective clothing, for instance boots, by supercooling steel and rubber. It also burns very clean, with less visible flame. Its greater radiant heat makes it more difficult to get close to the source of the fire. Propane at -40 degrees can cause similar problems. Whether the fire is caused by LNG or LPG, as surfaces heat up beyond 200 degrees Celsius, water droplets are deflected by the steam level and so become less effective. The longer the fire has to create heat, the more difficult it becomes controlling it. So all firefighting equipment and clothing should be stored for rapid access. And staff must be aware of its location. The key to extinguishing any fire is first to control it. Then the flame area can be minimized. And finally, fire extinguished. It is important to understand the four components that sustain a fire: fuel, air, heat, and the chain reaction. If any of these can be removed, the fire will cease. As a result, there are four ways to fight fire. The most important is to starve the fire of fuel by shutting off supply. Next is to choke off the supply of air. Cooling through evaporation is essential to limit the spread of fire. Once the other elements are in place, it is possible to break the chain reaction at the source of ignition. There are four technologies available to fight the fire. To starve the fire of fuel, there are emergency systems to shut valves and stop pumps. There are passive systems, such as melt plugs on deck, which activate shutdown systems at around 100 degrees Celsius. There is remote control through the product management system. And finally, there is the ability to shut off fuel by closing valves manually. Enclosed cargo machinery spaces are provided with a fixed fire extinguishing system suitable for the cargoes carried to smother the fire. However, it is important to evacuate spaces before they are used. In mast risers, nitrogen may be injected to smother the fire. CO2 released at pressure can cause ignition through static electricity, so it must only be used to extinguish fire and never be used to inert spaces not on fire. Outside, the key to smothering is high expansion foam. While rarely successful in extinguishing liquefied gas fires unaided, foam is invaluable in reducing the rate of burning of pool fires in drip trays and bunded areas. Once again, if the fire is to be got under control, it is essential to reduce the radiant temperature rapidly. Foam acts to reduce the rate of vapor emission. And if the vapor is unignited, helps minimize the risk of ignition. Large amounts of foam are required. For LNG and LPG, the foam, if available, should be optimized to create a blanket to minimize vaporization through insulation and by reducing contact with air. By its nature, foam is ineffective against jet fire. Water is the most effective medium for cooling. Gas containers are deluged to reduce the evaporation rate due to the heat of the fire. Large volumes of water may be supplied by firefighting tugs. Water is used to reduce damage to pipes and valves, to protect personnel operating valves, or to create a barrier to prevent the fire spreading from vessel to shore. Water can also be used to disperse gas, but it does not normally extinguish fire unless the gas can be dispersed by water spray at high volume and pressure. However, water must be used with care, especially where liquid gas has pooled. Its effect here is to cause the liquid to boil faster and make the fire more difficult to Newer technologies, such as water mist, both cool and smother the fire. Inhibiting agents are the key to extinguishing fires. Dry chemical powder is the most common ingredient. It works by breaking the chemical reaction of the burning process. For a pool fire, the idea is to create an envelope over the liquid gas. The normal technique is to work from front to back, taking care not to stand on the extinguished liquid. Care must also be taken not to disturb the surface, as this reduces the effect and can spread the fire. However, once extinguished, as hot surfaces and liquid gas are both present, the vapor will often reignite. Equally, any flame left after the attack will reignite the pool, so it's best to delay the attack until sufficient dry powder is available to kill the fire in one go. In shore installations, dry powder is often used in conjunction with foam to extinguish any remaining flames above the foam blanket. However, care must be taken to ensure that the dry powder employed is compatible with the foam. Dry powder is also effective in extinguishing jet fires if the right techniques are used. Frontal or side attack rarely works, merely being deflected by the jet of powder is best aimed at the base of the from behind, so that the powder follows the direction of the flame, mingles with it, and breaks the chemical reaction. Although the fire may have been extinguished, large quantities of unignited gas may still be released unless the source is controlled. For enclosed space, such as compressor rooms, there are also gaseous extinguishing agents that act through chemical inhibition rather than oxygen depletion. In emergency, events escalate rapidly, but a rapid response depends on everyone understanding their role and playing their part. Emergency plans are essential for both terminal and vessel. The plan must be up updated regularly. And understood by all crew and staff. Emergency control must be the responsibility of an identified officer or manager. Firefighting roles must be identified. Isolation and fire response actions must be coordinated. To achieve this, there must be a pre-arranged shutdown and system isolation plan. Firefighters must be informed of the plan before tackling the blaze. STCW and SOLAS for vessels, and SAVISA and similar national regulations for terminals require that crews and staff are trained in firefighting. Practice drills should be held regularly. Each drill should include a briefing before and an assessment after the exercise. Fire and gas systems should be tested regularly. Every member of the firefighting team should wear the correct PPE and practice putting it on fast. Practice working in difficult conditions. And practice using an emergency escape breathing device. In addition to the on-site or on-vessel training, it's good practice to undertake training with real fires in a controlled environment ashore, known as hot training. Nothing else prepare firefighters for the speed of conflagration, the heat, and the importance of a well-thought-out approach to tackling a blaze. In some countries, hot training is a regulatory requirement. Other good practice includes making fire rounds inside accommodation after a watch. Reporting fire hazards and near misses, and maintaining a vessel-specific fire training manual. Ideally, no one should ever have to fight a fire. If they do, it's because someone or something has failed. And the point of greatest risk is during product handling. The best defense against fire is prevention. Through high levels of personal training.
Okay, so here we have the main fire department.
Risk awareness. And product familiarization. Clear and simple product handling procedures are essential. Maintaining strict adherence to these, especially regarding fire hazards, is key to reducing risk. Each product has an MSDS material safety data sheet describing its characteristics and procedures to be followed. Vigilance is essential, especially prior to docking and during product operation. Pre-arrival checks should be undertaken by both vessel and terminal. They should be thorough, follow checklists, and the results should be recorded. On arrival, the ship's shore safety checklist should be completed jointly before cargo operations begin. There should be regular inspection and maintenance of systems such as valves, pumps and seals, gauges and domes, hoses, manifolds and pressure management systems. Accurate record keeping of inspections and maintenance is essential. On the vessel, fire wallet must contain an up-to-date crew list, cargo plan, and fire plan identifying the type and location of firefighting equipment. For vessels, these principles apply equally to any visits to dry dock or repair yards. Fire rounds, daily safety meetings, and inspection of vital equipment should all continue as normal. If a fire starts, it's too late to take equipment. Rapid deployment is crucial. All firefighting clothing should be checked and in position. Breathing apparatus should be tested and tanks pressurized. Regular inspection and testing should include gas and fire detection, automatic and manual emergency shutdown systems, fire pumps, water, dry powder, inert gas, and foam systems. Handled properly, liquid gas is very safe. This industry's excellent safety record is not down to luck. It has been achieved by high levels of training, good equipment design, and by implementing systems and procedures developed through experience over many years. Your safety depends on understanding the nature of liquefied gas, understanding the risks involved in product handling, and following agreed procedures precisely. Regular inspection and maintenance of product handling systems will go a long way to preventing the failures that result in fires. Beyond that, regular inspection and maintenance of firefighting systems, together with understanding and practicing firefighting techniques, will ensure that should the worst happen, you will be able to respond effectively to manage the hazard. The more closely these principles are followed, the less likely you are to have to employ your firefighting skills in practice.
Okay, what we will do is, we'll break for lunch. We'll come back at 1 o'clock. I will brief you about STS operations. Today we are going to do 2 STS operations on the bridge. Okay. We'll try to bring a ship alongside. When it is at anchor, we'll try to do an STS operation. Both will be very interesting. We'll put all of you on the same bridge, the 360-degree bridge, and you will work as a team and think a lot. That's what I want you to do. Apply yourself. Yeah, you did apply yourself yesterday, but then at a point when you stop applying yourself, you realize that a simple thing became so difficult. So again, slow and slowly. Any doubts so far? No. Okay.